Welcome to Lesson 06, Networking Basics, the Operations Way. Here's the premise. Site is down has 7 possible causes, from a dead link to a crashed app, and junior engineers waste an hour guessing while senior engineers walk the stack in 5 minutes. We'll cover 4 modern tools: IP and SS for interfaces and sockets, dig and host for DNS, ping, traceroute, and MTR for the path, and TCP dump for the actual packets. The rule is simple. Don't guess, walk the stack. Each layer has its tool. So let's name them. Failure 1 is the link or IP layer. No interface, no address, nothing. You reach for IP link and IP a DR. Failure 2 is routing. You've got an address but no path off the box. That's IP route and traceroute. Failure 3 is DNS. The network works, the name doesn't. Dig and resolv.conf tell you why. And failure 4 is port or firewall. DNS resolves, routing works, but the destination refuses you. SS locally, NC or Nmap remotely. 4 layers, 4 tool sets. Memorize the mapping. Now here's the decision tree itself. 5 layers, 5 commands, 1 rule, top to bottom. Start with dig. Does the name even resolve? Then traceroute to check the path, ping to confirm the host is alive, NC to test the port, and finally curl to hit the app. The first layer that fails is your bug. Stop there, fix it, retry. That's the entire game. No guessing, just walking the stack. Before we walk that stack, let's update your toolbox. If you're still typing ifconfig and netstat, stop. They're deprecated and they lie to you about modern systems. Multiple addresses per interface, IPv6, network namespaces, containers. The replacements are IP and SS. Use IP for layers 2 and 3. Links, addresses, routes. Use SS for layer 4. What's listening, what's connected. These 12 commands cover 90% of what you'll do weekly. Learn them once, forget netstat forever. Toolbox ready. Now the first layer that actually breaks. DNS. Every HTTP request starts with a name lookup, so when DNS fails, everything fails. Dig is your tool. Verbose, scriptable, accurate. Use plus shortened scripts, full output when you're debugging, and the @ sign to query a specific server like 8.8.8.8 to prove whether it's your resolver or the authoritative side that's lying. Host gives you a one-liner for quick checks, and resolv.conf, etc. hosts, and resolv.conf tell you what your system is actually doing locally. 8 patterns, 95% of DNS debugging. Name resolved, but the page still won't load. Now you walk the path itself. Ping answers one question. Is the host alive? It's a yes-no probe, but remember, plenty of cloud VMs block ICMP entirely, so silence isn't death. Fall back to a TCP probe with NC. Traceroute shows every router between you and the destination. So when hops 5 through 8 start timing out, you know the break is upstream of your provider. And MTR is the pro move. It runs traceroute continuously and pings each hop. So the connection feels slow, turns into hop 7 is dropping 50%. That's diagnosis, not guesswork. When ping says the host is up and curl still hangs, you've run out of higher level answers. That's when you reach for TCP dump and look at the actual packets on the wire. Most network bugs confess themselves in about 30 seconds. A TCP reset, a handshake that never completes, traffic leaving from the wrong source IP. The daily incantation is sudo TCP dump -i any port X, no name resolution, all interfaces, filtered to the port you care about. And when you need a second pair of eyes, write it to a PCAP with -w and open it in Wireshark. Step back from the tools for a moment and look at why this approach works. Networking is the most debugged by guessing area of operations, and that's exactly why systematic thinking pays off so much. 3 principles hold it all together. Layers exist because that's how problems isolate. Find the failing one first. ICMP is convenient but not authoritative, so trust TCP probes over ping. And when higher-level tools start lying to you, TCP dump is the calm, honest narrator that shows what actually crossed the wire. So here's the cheat sheet. 12 commands, one per row, grouped by the layer they interrogate. Link, IP, route, port, DNS, path, packets, app. That's the full stack on a single page. Print it, pin it next to your monitor, and use it under pressure. After a month of varied real use, you won't need it anymore. But until then, this is your map. When something breaks, you don't guess which tool to reach for. You pick the layer and the command is right there. Theory only sticks when your hands do the work, so here are 3 drills, 30 to 45 minutes total. Start by mapping your own machine. Interfaces, addresses, gateway, DNS, listening ports. Then walk a real domain through all 5 layers. Dig, traceroute, ping, NC, curl, and feel each step succeed. Finally, fire up TCP dump and watch an actual TLS handshake cross the wire. SYN, ACK, ACK. Do these today, and next time something breaks, you won't guess. You'll walk the stack. Now, 5 mistakes that burn hours in production. First, assuming a host is down because ping fails. Most cloud firewalls just block ICMP, so confirm with a TCP probe like NC or curl. Second, ifconfig and netstat are dead, IP and SS are the modern replacements. Third, always run TCP dump with N or your own DNS lookups end up inside the capture. Fourth, on Ubuntu, edit resolv.conf, not resolv.conf. System rewrites it. And fifth, the big one, don't restart networking to make a problem disappear. Diagnose first, restart last. The pattern across all 5. People skip layers or trust the wrong tool. And that's networking. You've got IP and SS for the local stack, dig for DNS, traceroute and MTR for the path, and TCP dump when you need ground truth on the wire. Next up, Lesson 07, SSH Deep Dive. Keys, agent forwarding, jump hosts, and a proper SSH config. It's the single most used remote tool in your career, so we'll master it once and close out the operation stage. See you in 7.